We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.
Hey math lovers, let's go over skills practice 5-on-1, letter B. Let's talk about this introductory video. We're going to talk about the population, and the population, I want you guys to think about it, is basically all. You know, think about you're watching a movie and all of that popcorn in that bag, it's all of it. Well, then you reach inside the popcorn bag and you grab a handful. I'll just call that sum. That's sum of all of the popcorn. That's part of all of it, or the whole. That's called a sample. Okay? Let's talk about some other definitions here. We have something called the mean. And the mean is the average, and we change colors there. It's a big word. That's a simpler word, the average of a set of data it's basically you're taking the sum of the data, the sum, and that's a symbol of sigma, the backwards E, it's a Greek letter. Sum of the data divided by, I can't spell divided by the size of the data set. And that would be a lowercase letter n. So, if with the population, the mean of the population, so mean population is this symbol, mu, it's pronounced mu, it's a Greek letter, equals the summation of all those points divided by n. Okay, that's what the mean is. That's the symbols there. Now, if you have a sample, like you just took the popcorn, that's called x bar. And that is, again, the summation of all of the data, adding them all up, divided by n. Okay? Okay, where is the mean? The mean is a measure of center. Let's write that. Measure of center. I can't spell. Okay, so for example, let's just say on this bell curve, this is normal, right? We learned last time it's called symmetrical, because if I cut it in half, you know, half will go to your brother, half will go to your sister. Well, here is our mean. Now, we're not sure if this represents the population or this represents a sample, so we're just going to call this the mean is 2.6. Okay? So in this case, some more advanced knowledge is that mean is equal to the median. That's why it's normal, symmetrical, bell curved. All right, let's talk about something called the standard deviation. The standard deviation, its definition is it's the data spread. I'm going to highlight that word, spread, and how spread out the data is from the mean. So the starting point is the mean and you're going spread out, okay? The standard deviation of a sample so we call that sample standard deviation, that's my abbreviation. They're going to have the letter just S, italicized S. If it's a population standard deviation, you're going to have this symbol, which is in Greek, it's an O with a little tail, and that's called sigma. Okay, so let me help you identify where is the standard deviation in this problem. Okay, from the center, this here, the difference here is really, we call this a +1 standard deviation. And really what you can do is you can just subtract and take the absolute value, okay? So watch this. I'm going to take 3 minus 2.6. Punch in your calculator and you get 0.4. So that means your standard deviation in this problem is 0.4. Now I want you to notice in black here, this is plus 0.4, right? This is one more standard deviation. This is 0.4. Okay, so in some ways from the center or the mean, this would be 2 standard deviations. Okay, if you added another one, this is, you just count them up. There's 1, 2, 3 standard deviations, right? From 2.6, you add 4.4, you get 3. Add 0.4, you get 3.4. That's 3 of them, right? 1, 2, 3. So if you went that far, that would be plus 3 standard deviation. And it's the other direction as well. If you subtract 0.4, you get 2.2. So this is just, we call this 1 standard deviation below the mean. Again, that would be 2 standard deviations, and so on and so on. So all you have to do is just subtract the numbers. Here, let me show you again. Watch. We took the absolute value, right? We did it this way. 2.2 minus 2.6 is going to give you a negative 0.4. Remember, if it's negative, it's going below the mean. And this one, the answer was a positive, so this is above. Okay? And that's how you find the mean and standard deviation looking at a normal distribution. I want to add 2 more things before we end. Standard deviation here will always be positive. And the reason why is we understand, well, your value will be, it could be negative, but if it is negative, it's going below. But for the answers for this set of problems, it's just going to be positive. The second thing I want to talk about is just kind of like a real life example. Okay, I don't know about you, sometimes for breakfast, is my bad, this is my piece of toast. Piece of bread, and you just put it in the toaster oven, kind of just put some heat to it, right? And oftentimes, I like putting jelly. And no one, I don't know, I don't like it when I just pop the jelly there and it kind of just stays there. What I want to do is take a knife and I want to spread it. I want to spread it all over, okay? So spreading the jelly is kind of this idea of standard deviation. It's spread out from the center or the mean where you started from. So think about my toast and jelly example. Example B1, we have a normal distribution, normal graph here. And in the middle, this is your mean. Your mean is 100, a score of 100 on an IQ test, intelligence quotients test. And again, the standard deviation, all I have to do is do a subtraction. Now, you can do this either way. I'm going to show you this. Now, if you take the absolute value of this, the standard deviation is 5. Why is standard deviation never negative? Well, again, this would be a +1 standard deviation going this direction, and this would be a -1 standard deviation. I can't subtract. I just realized that's a 100. And so that should be a -15 or +15. So again, your standard deviation will always be positive. For example, B2 here, we're supposed to find the mean and the standard deviation of this normal distribution. This is normal because it's symmetrical. And if you locate the middle, just put your finger or pencil at the middle. It's right here. That is our mean. Our mean is a measure of center, the center. But that's definitely going to be shifting later, but I just want you to help locate it. Snowfall inches, it is 55. Well, how do you find the standard deviation? I can just take these two numbers here and I'm just going to subtract them. And you'll get 0.8. So if I go from here, from the mean, this is going to be +1 standard deviation. That's essentially just a plus 0.8. And that's my answer. Now, if you do it the other way, just want you to note that +1 goes towards right, and then -1, or subtracting -0.8, right? 55 minus 0.8 would give us 54.2. So the negative is going towards the left. And you could do the same thing, right? If you wanted to go -2 standard deviations, you would just subtract -0.8 twice, or -1.6. And that's how you find the mean and standard deviation for question B2. B3, we just need to find the mean, or identify it. So the mean is a measure of center. Look at here, right in the middle, or center. This doesn't always happen, but it happens with a normal distribution graph. This one right above. So our mean is 98.3. To find the standard deviation, you're just going to guess, not guess, but how much does this number increase from 98.3 to 99? Well, you would have to add what? 0.7. Right? And then this makes sense because this one's also 0.7 and this one's 0.7. So you're basically adding 0.7 all the way across, or in this direction, going left, that is subtracting 0.7. So if you took the absolute value of those, our standard deviation would be 0.7 is our answer. B3, the 98.3 is our mean, and 0.7 is our standard deviation. B4 here, guys, we're looking at this normal curve, and in a normal curve, a measure of center is called the mean. So look at the middle, or center, and 24.8 is our mean. Okay? And next, I need to find something called the standard deviation. The standard deviation, all you have to do is just subtract the two numbers. Now, you can subtract it either way. It does not matter. I'll just subtract here. And I got 6.2. So from 24.8 to 31, you are adding 6.2. If I add 6.12, and here, this is how you double check your answer. It's just going to be 6.2 on all of these. Or if you took 24.8 and you subtracted 6.2, you would get 18.6, and so on. What I'm trying to show you is that that number that keeps repeating is what number? Is 6.2. So 6.2 is our standard deviation. And that's actually, I forgot to write units here, so this is miles per gallon. And 6.2 is also miles per gallon. Those are our units. Don't want to forget those. Box my answer. There you go. All right, B5 here. Let's go ahead and identify the mean, which is a measure of center for a normal distribution. That's right in the middle. So our mean right here is 10.5, and our units is inches. The standard deviation here, you're just going to subtract the two numbers. So if I subtract these two numbers, right, I get 2.1 is our standard deviation. And again, that's also measured in inches. And again, you can always just check your 2.1, your standard deviation for each of these. You notice that you're always adding 2.1, 2.1. And if you go in the other direction, a negative number just means you're going towards the left, or it's below the mean, or the blue part. And you can always just keep subtracting 2.1. So there is our answer for B5. In B6, I'm asked to find the mean of this normal distribution. Distribution is just a graph, and the mean, or the center here, is 500. And I'm not sure what the units are. You can call it 500 points if you want. Again, that's right in the middle there. The standard deviation is just how much do I need to add to get to 550. Well, that would just be 50 points. My standard deviation is 50 points. The spread is 50 points, right? You just notice this, you just keep adding 50 here, 50. This is one standard deviation. You know, if you went this direction, notice from 500, you can do what? Subtract 50, and that is one standard deviation. We call it below. We don't usually say a -1 standard deviation. That's kind of like we call it a -1 z-score. We'll just say it's below the mean. So that's our answer for B6.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today.